We will now look at an example where we read a temperature sensor over I2C. The temperature sensor is located on an embed shield attached to our evaluation kit. The temperature values will be sent over Bluetooth Low Energy. So here we see our workspace where we have a number of u-blox library files that are provided by u-blox to facilitate accessing Bluetooth functionality and other functionality available on the u-blox module from JavaScript. We also see what we have an init file, and in this init file we will load the needed libraries. We can load as many as we like, but here I've chosen to just load the ones that are actually needed for the example. And then we will load the actual source code, for example. Before we look at the example source code, I will introduce you to the u-blox stream concept, which is used in this example. Streams is a u-blox concept that will allow you to connect different data sources and syncs to each other. It can be any data source you can connect to your module. So for example, for modules that have Wi-Fi connectivity, we can have TCP and UDP connections. For modules that have Bluetooth Classic, we can have the Bluetooth serial port profile. And for Bluetooth Low Energy, we can have the u-blox serial port service, which we will see later. We can also have UART, I2C, which we will also use, and MQTT service. A stream is defined using a URL-based scheme. So basically you say the scheme and then have a scheme-specific part that's normally some kind of address. So for example, for the Bluetooth Low Energy serial port service, we have the scheme SPS, and then we have an address, which is a Bluetooth MAC address. For TCP, we have the scheme TCP, and then the IP address and the port. For I2C, which we will see later, we have the scheme I2C, and then we point out the I2C bus and address. And then we have some additional parameters like the bus frequency, and in our case the read frequency and which register we read from. And the fantastic thing about these streams is that you can connect them together and basically pass data from one data source to another seamlessly without any interaction. And we will see in this example that we will have our temperature sensor connected over I2C, and we will connect that stream to a serial port service and then seamlessly transfer the temperature readings over Bluetooth. As we've seen in our example, we have the init file where we load all the necessary libraries, and we see what we have a stream library, which we will use to define our streams, and then we also have a gateway library that we will use to connect streams together. And this loads the actual source code of our example. And if we go into that source code, we see that it's quite short. What we do here is to just in the beginning do a debug print to show that we have started, and then we define our I2C URL. Basically we say which bus, which address, bus frequency, how often we read, so we read every 5 seconds, and then we read from register 0. Then we define an SPS URL, so that this script will act as a server to let other modules or other Bluetooth units connect to it. So we will define a server URL here, so no other address, but just a server URL. And then we will just do some initialization of the module. We will define it as a Bluetooth Low Energy peripheral, which lets other Bluetooth Low Energy units connect to it. And then we'll start up the system. And then we will create our stream, the I2C stream, and connect it. And now it will start reading temperature sensor values. And then for our other stream, the SPS stream, we will create this stream with a callback here. And this callback, as we see here, this will connect the streams together once another device connects to our SPS server. So when we have an incoming connection, we will do a connection, and then when the connection is really set up, we will bind these streams together using these two simple calls. So we will connect the SPS stream and the I2C stream. So this is quite simple, very little code to create this sensor gateway. So let's run this and see what happens. And we will now send all the files down to the module, and it will restart and start executing. And then we will connect another module to our server over Bluetooth Low Energy. So the device restarts and it is now executing. So now we are actually reading temperature sensor values and waiting for an incoming connection. To connect to our temperature sensor, we will use another u-blox module running u-connectScript, which you can learn about in another video. To handle this module, we use the S-Center application from u-blox, which is an interface application that makes it easy to handle the AT command-based modules. So what we need to do in order to connect to this other module is to set this as a central, which is the role used when connecting to other modules. So we'll define this as a central, and then we'll store, then we'll connect, and now the connection is set up. And in order to display the values properly, we will check the hex button here, and then we'll enter data mode. And now we see the temperature measurements coming every 5th second as expected. And they are 1B, which I think is 27 degrees Celsius. So quite hot here in the office. And this is how simple it is to connect to our temperature sensor.